A year or so, Tim Berners-Lee started, because RDF is a very technical term, he's talking more about linked data. And there's a nice TED talk about linked data. So the idea here is that basically triples. RDF is a very simple idea. Subject, predicate, object. My name is Zvi. I am your friend. Yeah? My eyes are brown. Simple as that. And lots of, so here's an example, but of course the things, and each, the subject and the predicate and potentially the object, are all URLs. Okay? So he wants to say that the book, Tony Benn, has a title, which is Tony Benn, as an example. Okay? So there's a URL, and he's using Wikipedia here to define the subject. He's using here a standard set of vocabularies for the predicate, title, like an attribute basically, right? An attribute or relationship title. And the value could either be another URL or it could be a primitive, a string or a number. That's all RDF is. RDF is just a subject, which is a URL, a relationship, which is a URL, and an object, which is either a data type, like a number, or it's a relationship. So two examples would be Zvi's height is whatever it is, 180 something. So that would be a primitive object. Or Zvi's mother is Ruth. And that would be a URL. The object would be a URL there as well. And again, Tim Berners-Lee's vision is that there will be millions of these things all spread around the world, and the computers are going to crawl them and understand it all. And that may be happening, but I think it's actually working out a little bit differently. There's some increase in adoption of this. Of course, there's a query language called Sparkle, which is sort of SQL style, but it's RDF. And adoption is still limited, and especially, you see, the real problem with RDF, in my view, and we've got Wes Eitan, he may have a different view, because I think Semantinet, he's going to speak a few words afterwards. There you are. You're using RDF more, right? So you may give a counterpoint to this. The challenge with RDF is, first of all, okay, subject, predicate, object. That's a good idea, a simple idea. It all depends, though, is there a standard way, are there standard values for describing the subject and the object? And of course, somebody else may want to describe this book, and they may not choose the Wikipedia article, they may choose a different URL. So we need a standard way to assign unique URLs to real things. What's my URL? Is it a Wikipedia article about me? Is it a Facebook page? Is it my Google profile? So we need some standards for defining the real world things. And RDF doesn't give that to you. And we need standard vocabularies for the predicate. What's the official way to say mother? So it all depends on having the right standards for the actual data, and that's where RDF in itself doesn't provide any solutions. So the other way, which I think, as far as I can read, this is what's happening more, is that instead of a semantic web, people are creating semantic databases, which are more centralized. And the advantage of that, of course, the disadvantage is it's more proprietary. Someone is controlling the data more. But the advantage is they can create standard unique IDs and standard vocabularies. Yeah? And also, when you get all the data together, you can index it. So you can create much faster queries. So I think this is what's happening more, and I'm going to show, I hope, a few examples of interesting projects which are more centralized, I guess. Okay, it allows for control on the indexing, and it can be either general or it can be in a specific domain, so we'll see examples of both. And then you can still use RDF, even if you have there are RDF databases, like Virtuoso is the most famous, and I think Semantinet have one. And you can also use JSON. And what interests me most, in my project, is making all of this available as an object graph, so that Java or C++, C# can interact with the data just as easily as with any other object graph. So I'm trying to bring this stuff, into the formats which are most familiar to all of us. So why a common object graph? You know, if you have a more controlled object graph, or it doesn't have to be objects, but that's the most familiar way, then I can give a unique ID, right? I can say, you know, Zvi has this ID, which makes the information more valuable. So there's interoperability, I can correlate data between things, I can drag and drop in the GUI. Of course, this allows you to query, so you know, do all sorts of searches, and then also, when you bring data together, there are new possibilities to visualize the data, new possibilities to navigate the data, so it gives a lot of interesting opportunities. So let me just give you very small examples very quickly of what this looks like, yeah, to make it practical. An ontology tells us what are the categories of things, or in technical terms, the classes of things that are out there. So in the world, there are people, there are men, there are women, there are products, there are locations, etc., etc., etc. We have the classic is-a relationship, which in programming is often called inheritance or subclasses. So a man is a person, a woman is a person. And I've used this arrow to say is a, yeah? And then we have the has a relationship. A person has a location. A person owns products, right? These are the relationships or the attributes. And this is, again, very familiar from object-oriented programming as well. But the aim now is to do it on the real-world objects and vary across many domains. And then once you have the ontology, you can create specific data. So you can try and create a unique ID for the tennis player Roger Federer, and he can have links to the games he's played in, and he can have a link to the country he's a citizen of, and he can have a link to the product he endorses, which then relates into other people who endorse the same product, and the product belongs to a company, and this is the whole web of data which fills our whole world. Yeah? So let me summarize the vision and then move on. The main vision is to have a standard API so that apps can read and query and call methods about all the information in the real world. The core idea, and again, the hackathon is not limited to the core idea, it can be much broader, but the core idea is to have machine-readable data about the world. And I wrote this slide, you know, even before I knew that this is part of the Open Data Hackathon series worldwide. So this is all about computer-readable open data, which must include both the ontology, the model of the world, as well as the specific data. It can be distributed using RDF with lots of little bits of data, but I think that what's happening more and more, as I said, is that it's being somewhat centralized. There are some big databases which become the de facto standards. And I want to mention also that, you know, having an API, data, and methods for the world, this is the core idea. But other things that people are doing are natural language processing, so trying to take human data and make it readable to computers. And there's more and more bits of natural language processing are happening. Of course, computers have to interact with humans, so speech synthesis, speech recognition, automated reasoning. So once computers can access the data, now they need to analyze it and make decisions and help us, you know, use the data in a good way. So that becomes very interesting. And also all kinds of interesting ways to visualize data. And I brought here a very small video clip, which is a classic. Some of you may have seen it, but I love looking at it again. Just a very simple idea of how to visualize... Sorry. A very simple idea of how to visualize data in the real world. This one is three-dimensional. The data is only two-dimensional, but it's three-dimensional because it develops in time. And it's just a 1-minute clip, which... why have I got my order wrong here? I better jump to it now that I mentioned that.